So moving on to question number 18, we have a homogeneous flexible rope which rests on a wedge. So first we have a wedge. The angles of the wedge are alpha and beta as shown with the horizontal. On this, we place a rope. So suppose this is the half part of the rope and this is the other half of the rope. And the central part of the rope lies at point C, which I have marked here. So we have to find the acceleration with which the wedge should be pulled to the left. So acceleration of wedge, let us say, is A towards left to prevent displacement of rope along the wedge. So let us see how to solve this question. So let us consider first half part of the rope. Its weight will be m/2g in downward direction. Normal reaction by the wedge on the rope will be in perpendicular to the surface. And other than this, there will be a tension force T in upward direction. So these are the forces on left side of the rope. On the right rope, we have force m/2 into g, again in vertically downward direction, tension T up the incline, and normal reaction, let us say N2 perpendicular to the incline. Let us now resolve the forces. So I'll resolve m/2 into g. So the component will be m/2 into g sine alpha down the incline, and another component will be m/2 g cos alpha. So these are the two components of m/2 into g. Other than this, we have an acceleration A, whose component down the incline will be A cos alpha, because this angle here is alpha. So these are the forces which we have. Finally, the component of acceleration perpendicular to the incline will be A sine alpha. So this is the free body diagram of the left side of the rope. For the right rope, we have components of m/2 into g. One is m/2 g sine beta. Another is m/2 g cos beta. Also, we have the component of acceleration. So suppose this is acceleration A. So the component of acceleration along the incline, it will be A cos beta, and perpendicular to the incline will be A sine beta. So this is the free body diagram of right side of the rope. Then let us write Newton's law equation. First, I will write Newton's law equation for left side of the rope. So along the incline, I have m/2 g sine alpha minus tension force is equal to m/2 into A cos alpha. So this is the first equation for left side of the rope. For right side, so for right side rope, we have T minus, see, acceleration is in this direction. So T will be bigger force, minus m/2 into g sine beta is equal to m/2 into A cos beta. So these are the two equations along the incline. Now on solving, we'll get acceleration A as g bracket sine alpha minus sine beta upon cos alpha plus cos beta. How will we be able to solve? We will add the two equations. So I'll have 1 plus 2 equations. So when we add the two equations, minus t plus t cancels, and we get the value of acceleration as shown in the diagram. So this is the answer to question number 18. So I hope you understood question 18. So let us move on to next question, which is question number 19. So in next question, question 19, we are given a chain of length L, which is placed on a smooth spherical surface. So suppose this is the smooth spherical surface. On it, I will place a chain. So this is the chain. Now, the chain I have shown in golden color. In this case, the length of the chain is L. In this case, the radius of the spherical surface is r. Now, in this case, we have to find the acceleration of each element of the chain when its upper end is released. So when we release the upper end at point, let us say A, so what is the acceleration? That is what we want to find. We have to assume that length of chain is less than pi r by 2. So let us see how to solve this question. So in this question, we will use linear mass density, the concept of linear mass density. So linear mass density lambda is m by L, mass of chain upon length of chain, that equals small mass dm upon small length dl. So from this, I will get value of dm. It is m by L into dl. So dm becomes m by L into dl is r d theta. Why? Because if I consider any element of the chain, let us say I consider some element. Let us show the element here. Small element I am considering. This is the small element of chain which I am considering. Suppose this makes an angle d theta. Suppose this element makes an angle d theta, and the radius is r. So the length of element dl, that will be nothing but r d theta. By using the mathematical formula S is r theta, we get dl is r d theta. So that is what I am substituting here. dl is r d theta. Now, the force acting on this element, df, small force on this small element here. So we will have mg force here, which will be dmg. Its component along the surface will be dm into g sine theta. Just like we have mg sine theta, here we will have dm into g sine theta. And dm value will substitute here, m by L into r d theta into g sine theta as it is. So df will come out to be m by L into r g sine theta d theta. So let us now integrate. So on integration, we'll have what? Total force capital F, it will be m by L into rg. Limits of integration is 0 to, let us say, some angle alpha. So let us say this chain is from 0 to alpha. So let me mark the limits. So this is 0 and this whole angle is alpha. Okay. So our integration will come out to be m by L into rg. Integration from 0 to alpha sine theta d theta. Sine theta integration, what is the integration? So sine theta integration will be minus cos theta from 0 to alpha. So it will come out to be m by L into rg minus cos alpha minus of minus, which is plus cos of 0. So total force F, it will come out to be m by L rg cos 0, it is 1. So 1 minus cos alpha. So this is the value of total force F. Now if I write this alpha as, in this case, let us think what is the value of alpha. So if I use this diagram here, so this angle here is alpha, this is radius r, and this is length L. So what will be the equation? S is r theta. So S, in place of it, will have r into alpha. So alpha will come out to be L by r. So we can substitute alpha as L by r in this equation. So our force will come out to be m by g in m by L, sorry, m by L into rg, 1 minus cos of L by r. So this is our final answer for total force F. So I hope you understood this question number 19. Let us move on to our next question, which is question number 20. So we have our question 20 on page number 37. So on page 37, we have question number 20 of our class notes. In that case, we are given a man. So there is a lift, and in it we have a man. The mass of man is capital M, who is standing on an elevator. So there is an elevator, And the man is standing on a weighing machine, which I'm showing you. So this is the weighing machine. Now, in this case, the lift is accelerating upward with an acceleration A. So let us consider we have to have what? In this case, we have to draw the free body diagram of the man. We have to draw the free body diagram of the man according to observer on ground. And the diagram of the man according to observer inside elevator. So let us see the free body diagram of the observer on ground. So one force on him will be mg in downward direction. Another will be normal reaction in upward direction, and acceleration will be in upward direction. So in this case, the equation will be n minus mg is equal to ma. So n is mg plus ma. So, and here is apparent weight. That is mg, which is actual weight, plus ma. So which of these will be greater? Of course, apparent weight will be greater than actual weight. So the man will feel heavy. Then for observer on the inside the elevator. So what are the forces acting? So one is mg in downward direction, normal reaction in upward direction, and we'll have a pseudo force because the lift is accelerating upward. Pseudo force will act in downward direction. So our equation according to observer inside elevator will be n is mg plus ma. So again we have the same answer. Apparent weight is greater than mg, which is actual weight. So this is how we'll solve question number 20. The value of n from both the observers, observer on ground and observer inside the elevator, will have same Newton's law equation. So this is question number 20. Let us move on to our next question, which is question 21. It is again on page 37. So we have a bob of mass 50 gram. So this is the trolley. And this is the ceiling of the trolley. From there, we have a bob of mass 10, making an angle theta as shown. So the angle theta is given to us as 37 degrees. So in this case, we have to find the acceleration of the trolley. So let us think about the forces acting on the bob. So this is the bob, one is tension force. If we consider ground frame of reference, so from ground frame, we'll see that the bob is accelerating a acceleration. There is another force mg. There is this component of tension. So this angle is theta according to geometry. So this is t cos theta. And this is t sin theta. So here t sin theta equals ma because force is mass into acceleration. And t cos theta is mg, equation 2. If I divide these equations 1 and 2, I will get tan theta is a by g. So acceleration comes out to be g tan theta. So this is from ground frame of reference. Now, if I observe from this trolley, so what is the free body diagram? Pseudo force ma in backward direction. Because the trolley is accelerating forward, pseudo force will act in backward direction. Mg will act in downward direction. Tension will act in this direction. So we can use, let us say this angle is theta. So component of tension will be t cos theta, and this component will be t sin theta. So t sin theta balances ma, and t cos theta balances mg. So again, if I divide these two equations, I will get tan theta is a by g, giving the value of acceleration as g tan theta. So whichever frame of reference you use, whether you use ground frame or trolley frame, the answer for acceleration will come out to be same. So this is question number 21. Now let us go to question number 22 of our debate. So in question 22, we have a bead of mass m. So let us first see the diagram. This angle here is alpha. So a bead of mass m, it is fitted to a rod and can move without friction. So this bead can move without friction. At the initial moment, bead is in middle of the road. So bead is in middle of the rod. The rod moves translationally. So rod is having a translational motion, acceleration A, making an angle alpha with the rod. So we have to find the acceleration of bead relative to the rod. So what is the formula for acceleration of bead relative to the rod? So it is acceleration of bead with respect to ground minus acceleration of rod with respect to the ground. So what is the acceleration of bead with respect to rod? So we are given in this case acceleration of bead with respect to ground. We have to find minus acceleration of rod is minus a because it is in negative direction. So acceleration of bead with respect to rod is equal to so this is the value. Now let us think about the acceleration of the bead. So in this case, let us consider AR be the acceleration of bead with respect to rod. So acceleration of bead with respect to rod. So now let us think about the components. So acceleration of bead with respect to rod will have two components. So we'll have X and Y component. One component will be acceleration of bead with respect to rod cos alpha plus A. Another component will be acceleration of bead with respect to rod sin alpha. Why will we have these two components? So in this case, AR acceleration of bead with respect to our cos alpha component. This is in the horizontal direction because the bead is moving in downward direction with respect to rod. So one component will be what? The acceleration of bead with respect to rod is in down the rod direction. So acceleration of bead with respect to our cos alpha and plus the acceleration of the rod itself and acceleration of bead with respect to r sin alpha. So this will be the other component. So what will be the equations, Newton's law equation along horizontal direction and vertical direction? So along horizontal direction, let us think about the forces. So one is mg force acting in downward direction. This is mg force. Other force is normal reaction and let us say, and its component along perpendicular directions will be what? So let us think this angle is alpha. So this 90 minus alpha, this will be the alpha. So n cos alpha will be in upward direction, n sin alpha will be in horizontal direction. So our equation along horizontal will come out to be n sin alpha. This is equal to mass into acceleration in horizontal, which is nothing but acceleration of bead with respect to rod cos alpha plus A. And along vertical, we will have mg minus n cos alpha is equal to mass into acceleration of bead with respect to rod sin alpha. So this will be the acceleration, Newton's law equation along vertical direction. So in these two equations, if I rewrite them as like this, n sin alpha is m into acceleration of bead with respect to rod cos alpha plus A, and n cos alpha is equal to mg plus m into acceleration of bead with respect to rod Sorry, here there will be minus sign. So let me get rid of this plus sign here. So there will be a minus sign here because when we take this on the right side, it is plus, and this on left side will be negative sign. So sine alpha. Now divide these two equations. If I divide these two equations, n and n will cancel, and from that, on solving, I will get the acceleration of bead with respect to rod. It will come out to be g sine alpha minus a cos alpha. So the answer to this question, acceleration of bead with respect to rod, it comes out to be g sine alpha minus a cos alpha. So this is how we'll solve question number 22. So after this, let us take next question, which is question number 23. So in next question, we have a pulley and a mass system. So one mass here, another mass here, passing through a string. So this is M1, this is M2. And the pulley is accelerating upward with an acceleration of A0. Now, in this case, A0 is the acceleration of pulley. We have to find the acceleration of M1 with respect to M2. M1 and M2, sorry. We have to find the acceleration of M1 with respect to elevator and acceleration of M2 with respect to elevator. So let us see how to solve this question. So let us find using ground frame. So let us solve this question from ground. So suppose this is ground. So what are the forces acting on each block? One is tension P in upward direction on both the blocks. Then let us consider the acceleration A1 of block M1 and acceleration A2 of block M2 with respect to ground. So what will be the value of A1? So in this case, let us think acceleration of 1 with respect to pulley. So let us consider the acceleration of 1 with respect to pulley. So A1 is the acceleration of M1 with respect to ground. That will be acceleration of 1 with respect to pulley plus acceleration of pulley. Why? Because acceleration of 1 with respect to pulley is acceleration of 1 with respect to ground minus acceleration of pulley with respect to ground. So acceleration of 1 with respect to ground is equal to acceleration of 1 with respect to pulley plus acceleration of pulley with respect to ground. So acceleration of 1 is equal to acceleration of 1 with respect to pulley plus acceleration of pulley. So from this I can say A1 will come out to be A plus A0. The value of A1 is A plus A0. Similarly, let us think about A2. So it will be minus A plus A0. Why? Because acceleration of 2 is with respect to ground is acceleration of 2 with respect to pulley plus acceleration of pulley with respect to ground. So pulley is moving up, so plus A0, and acceleration of 2 with respect to pulley. So it is moving down, so minus A. So A2 value will come out to be minus A plus A0. So once you have understood this, let us use Newton's law equation. So for M1, the Newton's law equation we can write. So for M1, T minus M1G, because M1G will act in downward direction, M2G will also act in downward direction. So our equation for Newton's law for M1 will become T minus M1G is equal to M1 into A plus A0. Similarly, for mass M2, we will have P minus M2G is M2 into minus A plus A0. Now, if I solve these two equations, let us say add these two equations, I will get the value of tension P. It will come out to be 2 M1 M2 upon M1 plus M2 into G plus A0. Also, if we substitute the value of tension in any of the above equations and get acceleration, it will be M2 minus M1 upon M1 plus M2 into G plus A0. So this will be the value of acceleration. So this is how we'll solve question number 23. Another method to solve question 23 can be based on non-inertial frame. Let us see the method 2 from non-inertial frame. So from pulley frame. So we'll use the concept of pseudo force in this method. So this is our pulley. I am sitting on the pulley. So this is mass M1 and this is mass M2. Now M1 free body diagram. We will have M1G force in downward direction, tension T in upward direction. M2 we will have M2G in downward direction, tension T in upward direction. Now because we are solving from non-inertial frame, there will be a pseudo force M1A0 in downward direction, M2A0 in downward direction on both the masses. Other than this, with respect to me sitting here, this will move with acceleration A in upward direction. This will move with acceleration A in downward direction. So let us write Newton's law equation. So because this M1 is moving upward, tension will be bigger. So T minus M1G plus M1A0 is equal to M1A0. And here Newton's law equation will come out to be, let me write this in a better way. This is M2. So Newton's law equation here, because this is moving downward, downward force will be greater. M2G plus M2A0 downward forces minus tension force is M2A. So in this case, here we will have acceleration A. Okay. So in this case, if I take these two equations as equation 1 and 2 and solve them, I will again get the value of T. It will be 2 M1 M2 upon M1 plus M2 into G plus A0. If we subtract these, add these two equations. If I add these two equations, 1 and 2, so on adding, we will get acceleration A. It will be M2 minus M1 upon M2 plus M1 into G plus A0. So this is how we'll solve this question. So on subtracting these two equations, we'll get the value of tension. On adding these two equations, 1 and 2, we'll get the value of acceleration. So this is how we solve question number 23. Now, moving on to next question of our booklet, which is question number 24. In question number 24, we are given two smooth blocks. So one block is small m, another is m dash. So these two blocks are kept on a smooth block wedge of mass capital M. Now if we apply a force capital F on the wedge, so in that case, so like slightly let's make another wedge. Let me draw a better one. This is a better one. Now, in this case, what are we expected to do? If a force capital F acts on the wedge, the blocks do not slide relative to each other. We have to find the acceleration of the wedge and value of force. So we have to find the acceleration of the wedge and force. So let us see how to solve this question. So in this case, let us see the free body diagram for small m on top, for m dash at bottom. So here we have m dash g. M dash g in downward direction. Tension T is the force in upward direction. Here tension T acts in forward direction. Acceleration is in forward direction. So there is also a normal reaction N1 in upward direction, Mg in downward direction. Here we have normal reaction of wedge on this N2 in forward direction. This N2 leads to acceleration A in forward direction. So Newton's law equation in horizontal and vertical. N2 is m dash A and T is M dash G. For this, T is MA in horizontal and N1 is MG in vertical direction. So these are the equations which we get here. Okay. Now in this case, we want to find the value of acceleration. So let us think how to find the value of acceleration. So if I consider these two equations, one equation and two equations, this let us say equation 1, this let us say equation 2. So 1 divided by 2 will give us T is equal to MA upon T upon M dash G. So PT cancels. 1 is N upon M dash into A upon G. So A comes out to be M dash upon M into G. So this is the value of acceleration A, M dash upon M into G. Now, if I want to find the value of T, so T will be just equal to MA. So T will be equal to M into M dash upon M into G. So M cancels. So T comes out to be M dash G. So the value of T finally in answer, it will come out to be M dash G. So the answers to these questions are T is equal to M dash G, one answer, and another answer is acceleration A is equal to M dash upon M into G. So these are the two answers. Now we want to calculate the value of F. So force F that leads to acceleration of the system. So acceleration is A, let us say, and total mass is M plus M plus M dash into A. So F will be M plus M plus M dash into A, which is M dash upon M into G. So this is the answer for F. So we found force F, tension and acceleration, all the things which are needed for this question. So this is how we solve question number 24. Now, moving on to next question, which is question number 25. So in question number 25, we have a wedge. On the wedge, we have a mass M. And suppose this wedge has acceleration capital A in right direction. The angle of wedge is alpha. With what acceleration A towards right should the surface move? So in this case, we are given there is no motion of this small m block. Let us think about the forces. Let us say this is capital M. A block of mass small m is placed on the inclined plane. With what acceleration capital A towards right should the system move over the horizontal surface so that small m does not slide on the surface. So small m should not slide. So if I consider the free body diagram of small m, if I'm sitting here, so there will be pseudo force small m into capital A in backward direction. Then there will be a force mg in downward direction, normal reaction n in upward direction, and this normal reaction will have two components. So one component will be, so this angle here will be, this is our diagram. This is 90 minus alpha, so this will be alpha. So this angle will also come out to be alpha. So the vertical component will be n cos alpha, and the horizontal component will be n sin alpha. The Newton's law equation is n sin alpha is ma, n cos alpha is mg. So if I divide these two equations, 1 and 2, I will get 1 divided by 2 gives sine upon cos, which is tan alpha, is capital A upon G. The value of acceleration is G tan alpha. So we can say the answer to this question, acceleration A is G tan alpha. So the answer to question number 25 is acceleration is G tan alpha. Okay. So this is one method by which we can solve this question. We can also solve this question from ground frame of reference. So from ground frame, even if you solve, you will get the same answer. What will be the change? Let us see. So from ground frame, we will have acceleration A, and this is mass M. So mass M, it will have acceleration A. Normal reaction will have two components. Let us say this is N, this is mg. So one component of normal reaction will be in this case. See, this is normal reaction. This is mg. So this angle is alpha. So this angle will also be alpha. So this will be alpha. So n cos alpha. This will be n sin alpha. So along horizontal, force is mass into acceleration. So n sin alpha is mass into acceleration. Along vertical, we will have equation n cos alpha is equal to mg. So if I divide these two equations, 1 and 2, I will get tan alpha is equal to a by g. Again, giving us the same value, a is g tan alpha. So whether you solve by ground frame of reference or wedge frame of reference, you will get the same answer. So this is how we solve question number 25. So after this, we will learn our next topic, which is fully constrained, and we will continue with our question number 26. So our next topic after this is constrained motion. So next topic which we'll study is constrained motion. So in it, we will first study fully constrained.